Hello, you're welcome back. Okay, so we are going to continue from where we stopped. So we are going to be looking at resistors in parallel. Okay, so when a resistor said to be connected in parallel, now they are connected, resistors are connected in parallel. Okay, if only the current that is entering into uh, the resistors actually varies or divides. Okay, for example, this is actually a supply voltage that flows through a parallel connection. So to show that these two resistors R1, R2, R3 are in parallel, the current will divide. That's a branch. Okay. So first the current divides, the one that enters R1 is I1. I call it I1. Then divide again. I2 will enter into R2. While of course I3, okay, passes through R3. So this is what shows that these resistors are actually connected in parallel. Okay, so the current that they are actually gonna take will based on their resistance. Okay, and it's gonna be in ratio. So it's gonna be in the ratio of R1 is to R2 is to R3. So the currents I1, I2 will be we're gonna okay will divide itself in this ratio. Now let's look at the characteristics. Now, one characteristics of resistors connected in parallel is that they have the same voltage all through. Okay, so the same voltage is going to drop across R1, R2, and R3, and that voltage is going to be equal to the supply voltage. Okay, and it's going to be it's equal, but the current actually varies. Okay, so the current will actually divides, and it will divides in the ratios of the resistance as I already mentioned. So which simply means that the total current now that is being delivered to the branch, okay, the total current I total delivered to the branch is going to be equal to the current passing through I1 plus the current passing through I2, okay, then plus the current passing through I3. And of course, from Ohm's law, we know very well that, okay, if we make I the solid of formula, I is going to be equal to the voltage divided by the resistance. Okay, so let's flow. So I total now is going to be equal to the voltage, which is constant, divided by the total resistance. For I1, the same voltage divided by R1. For I2, V divided by R2. Okay, then for I3, V divided by R3. All right. Now, since at the right hand side of this equation, V is a constant factor, so I have to factorize it. So I take it out as a factor, then I now have 1 all over R1 plus 1 all over R2, then plus 1 all over R3. So bracket close. So V cancels V. So I'm left with 1 all over RT. It's going to be equal to 1 all over R1 plus 1 all over R2, then plus 1 all over R3. All right, so that is how we find the total resistance of the resistors connected in parallel. So if resistors are connected in parallel, the sum of the reciprocal of the resistance, okay, is going to be of course, it's going to be the total, the equivalent will be the reciprocal of the equivalent resistance or the total resistance. All right. So that means invariably now, if R1 is 2 ohm and R2 is 2 ohm, R3 is also 2 ohm, and you are being asked to find the total resistance for these three branches, okay? The total resistance or the equivalent resistance, simple. So all I'm just gonna do is 1 all over R total is gonna be equal to 1 all over 2 plus 1 all over 2, then plus 1 all over 2. All right, so if that be the case, I'm gonna have 1 all over RT is going to be equal to LCM is 2, right? LCM of the denominator is 2. 2 divided by 2 is 1. 1 times 1 is 1. Then plus 2 divided by 2 is 1. 1 times 1 is 1. Plus 2 divided by 2 is 1. 1 times 1 is 1. So I'm having 3 all over 2. So if I should reverse, for me to find total resistance RT, okay, I'll simply have to reverse this fraction. So 2 comes up, 3 goes down, right? So 2, what I'll have is 2 divided by 3. So which is 0.67 ohms. Okay, so that is resistors connected in parallel. So now let's now solve questions based on parallel connection. I have a question here that I want us to do justice to. Okay, please pardon me. I bring it right here at the screen. So the question goes this way. What is the value of the unknown resistance R shown in the figure 1.18? This is the figure here, right? If the voltage drop across the 500 ohm is 2.5 volts, so invariably now they're saying that the voltage across this 500 volts is 2.5 volts. All right. So all resistors, of course, are in ohms. So how will I be able to get this resistance? I've have the supply voltage is 12 volts. Okay. All the resistance are being given, but there is just one that is actually missing. Okay. So it would have been easier for me to use Ohm's law. Okay. If I have the current, I would have used V total, which of course is the supply voltage, is going to be equal to current multiplied by the arrow total. So by the time you evaluate, if I have the current, but current wasn't given. But there's just one thing now I need to do for me to be able to get the voltage, to be able to get the voltage across R. How do I be able to get the voltage across R? If I can get the resistance, if I can, for me to get the resistance, please pardon me, not the voltage, okay? One thing I can do now to get this resistance, this unknown resistance, is to be able to get the voltage across R. And the voltage across R is going to be the voltage, okay, between C and D. So if I, and you know very well that this 50 ohms and the 500 ohms, all of it are connected in series, okay? So the whole of, and that's going to be between the terminal of C and terminal D. So if I can get the voltage, okay, across these two resistors, 50 ohms and 500 ohms, that same voltage that's across these two series resistors is the voltage, because these two series resistors, 50 ohm and 500 ohms, okay, their terminal is connected across C and of course across D. Okay, so whatever voltage it gives me will definitely be the voltage that is going to be across R. Why? Because it is a parallel connection. Remember, in parallel connection, all the branches have the same voltage. Okay, so which simply means that, remember, this current will divide. This is I. It will divide. Let's say the current entering R, this unknown resistance. Okay, as already stated, is I1, and the current entering the other branch. There are two branches. Okay, the current entering this other branch, and that same current is what is going to pass through 50 ohms and 500 ohms, okay, is I2. So that simply means that the branch that is having the current I2 plus the branch that's having the current I1, they are parallel, okay? I told you that parallel connection is actually, we get parallel connection when there's a branch, okay? The branches, all branches have the same voltage. So now if I can get the voltage, okay, across branch 2, that same voltage is going to be the voltage across branch 1, and that will help me get the resistance. Okay, so let's actually, let's do that. Let's do that. Okay, so how do I get that done? Okay, so let's flow. So the very first thing I'm going to do is I have to get this current across this I2, the current across um, branch 2, okay? And how will I get that I2? Remember, that same current I2 is across 500 ohms, and the voltage across 500 ohms is 2.5 volts. So that way I can simply say that I2, according to Ohm's law, okay, is going to be equal to voltage. And the voltage across the 500 ohms, well, that's 2.5, then divided by um, the resistance, voltage all over resistance, which of course is 500. So let's do that. 2.5 divided by 500. So I have 0.0005 ampere. So that is I2, okay? Passing through 50 ohm and 500 ohms is 0.005 ampere. So that way I can get the voltage, okay, for the second branch, V2. Let me call that voltage V2. So the voltage across the second branch is going to be equal to, according to Ohm's law, okay, the current I2, then multiplied by the total resistance across, okay, total resistance in that second branch. And the total resistance in the second branch is going to be 50 plus 500. Remember, they are connected in series, okay, so I have to add it up. So that's going to be V2, and that's going to be equal to, of course, I2 is 0.05. Okay, then of course multiply by 550. All right, let's multiply that. 550, that's 2.7 volt. 2 point, was it 2.75 volt, right? So that simply means, now let me now draw that. So that means the voltage across CD, all right, is 2 point, let me write that down, 2.75. Okay, now remember, so I've gotten the voltage across CD. Now the question is, how will I be able to get the resistance? Okay, and you know very well that for me to be able to get the resistance across CD, this resistance R, I still need to get the current. Okay, why? Because if I want to get that resistance R, okay, the R resistance by Ohm's law, that's going to be equal to the voltage then divided by the current I1. Of course, you know that already. Okay, so now, so how do I actually get that? The current I1. Okay, so all right. So for me to be able to get that current I1, I need to get the current, okay, that is actually passing through, the current that's passing through the 550 ohm resistor. Yes, I need to get the current passing through the 550 ohm resistor. Okay, please pardon me. So how do I get the current across the 550 ohm resistor? The very first thing I need to get the voltage across the 550 ohm resistor. And the 550 ohm resistor, okay, is actually in series with the entire parallel connection that has this voltage 2.75 volts. So invariably now, for me to get the voltage across this 550 ohm resistor, I'm going to subtract 12 from what I have, okay? So let me call the voltage across this 550 ohm resistor to be V1. Remember the voltage across the R, okay, that we've calculated is V2, and that's 2.75. So now for me to now get the voltage across the 550 ohm resistor, which is V1, okay, all I just need to do is to subtract the total, subtract 2.75 from the total voltage. The total voltage is 12 volts. That's 12 minus 2.75. All right, so let's do that. 12 minus 2.75. That's 9.25. So the voltage across 550 ohm is 9.25 volts. So now let's get that current, okay, the total current. So invariably now the total current I, okay, is gonna be equal to the total current I, which is passing, okay, passing through 550, 550 ohms, is gonna be equal to the voltage across 550 ohm. That's 9.25, then divided by 550. All right, let's do that. Divide this by 550. Okay, approximately 0.02. Let's make it 2. 0.02, if I'm not mistaken, ampere. 0.02 ampere. So, so if this is 0.02 ampere, okay, so it is this 0.02 ampere now that actually enters into this particular branch and divides, okay, divide into the one that enters, divide into I2. Remember, it is the total voltage I that actually reaches this node. We call this one node, the point where there's branch, okay? So this I actually divide into the current that's entering into R, which of course is I1, then plus I2, okay? So let me just write that down here. So it is this I that actually divides into, okay, I1, then plus I2, right? So it happens that I've already gotten I2. Remember, I2, we got it, and that was 0.005, okay? So now for me to be able to get I1 now is going to be equal to total current I minus I2, okay? So total current is 0.02, then minus 0.005. Let's do that subtraction. 0.02 minus 0.005. That's 0.015. 0.015. So I've gotten the current I'm looking for, okay? I1. So the current I'm looking for is, so that way now to get this resistance now R, okay? You know, we can now get that resistance. So the resistance R now is going to be equal to V1, okay, which we already know. We have calculated that's 2.75, then divided by the current, okay, and that current is I1. So that's going to be 2.75 divided by 0.015. Okay, so let's divide that. 2.75 divided by 0.015. What do we have? Okay, so approximately 183 ohms. So I hope that is well understood. Okay, though it's kind of long, but I'm very sure that by the time you go through it again, you get to understand. Okay, so let's still solve some more question. Let's still solve some more question. All right, I will pick more question. Okay, so here I have another problem that I wish to do justice to. Okay, so this goes like this. Two resistors R1 and R2 are connected in parallel. Of course, this parallel connection R1, okay, and R2. The total current drawn is 20 ampere. R1 is 30 ohms. Find R2. So that would be very easy. Okay, because in this case now I've been given voltage. I've been given the supply voltage, the total voltage, okay? And of course also I've been given the current, the supply current, which is the total current, right? So then of course I have to multiply by the total resistance. So from that total resistance now I can be able to get R2. So it's easy. So let's put the value. So here I have the 200 volt. The supply voltage is going to be equal to is going to be equal to, okay, the current, the supply current 20 ampere. And of course, it's that supply current that actually divides into these two branches. Okay, so multiplied by total resistance. So I have two resistors connected in parallel. Now remember how we resolve resistors connected in parallel. That means the R total. Okay, remember the formula. 1 all over R total is going to be equal to 1 all over R1 plus 1 all over R2. Okay, then you now resolve. But you resolve by evaluating the fraction, right? But I'm going to show you a shortcut, especially for just two resistors. When two resistors are connected in parallel, to get their total resistance, simple, you use the formula, okay? The total resistance is gotten by using the formula product all over sum. So please take note of that. So the total resistance directly, okay, without going through the long process of finding LCM, I'm gonna just apply the simple, okay, formula product all over the sum. So what's the product? Product of the resistance, the two resistance, that is R1 times R2, then divided by their sum, R1 plus R2. So that's exactly what I'm going to do here now, okay? So the two resistors is 30 ohm and R2. That's going to be, their product is 30 times R2, that's 30 R2. Then divided by the sum. And what's their sum? Their sum is 30 plus R2. Okay, so of course, you know what I will do here. I have to cross multiply. So cross multiplying, I'm going to have 20 times 30. Of course, that's going to give me 600. So I have 600 R2. Okay, of course, times 1, 600 R2. I have to cross multiply the other way. So 200 times 30, that should give me 6,000. 200 times R2, that's going to give me 200 R2. So rearranging this equation, I'm going to have 600 R2, then minus 200 R2 is equal to 6,000. So subtracting the 600 minus 200, right? That should be 400. 400 R2 is equal to 6,000. So that way now I can get R2. Now R2 is going to be equal to 6,000. Then divided by 400. Okay, so let's work on that. 6,000 divided by 400. That's 15. 50 ohm. I hope that is well understood. All right. Okay, let's flow with another question. Do I have any other? Okay, let me just work on this. Then we'll now look at some other laws, okay, in direct currents. That's gonna be Kirchhoff law and some other laws. So I'll solve this. This is a power connection. So the question goes like this: in the circuit shown in figure 1.29, calculate the current in all resistor. Okay. So of course, you know what happens in this power connection. The total current that's flowing is 10 ampere. It will divide, okay, among these resistors in ratio. So the 10 ampere, okay, which of course is the total current. The total current, okay, 10 ampere, will divide itself among these resistors, okay, in the flowing ratio, the ratio of R1 is to R2. How many branches do you have there? Okay, 4 branches. Is to R3 is to R4. But that will not be easy. Okay, why? Because first off, um, the resistance, okay, there's some no resistance here, which of course is X. All right, I have an unknown resistance, which is X. So if that's been the case, the very first thing I need to do is to find the resistance, this resistance X. How will I be able to find this resistance X? It is easy. Of course, this resistance X is what I call the arrow 2, right? So by virtue of branch, this arrow 2, by virtue of branch notation, okay, the S is arrow 2. If I take this one as arrow 1, this arrow 2, this is gonna be arrow 3, and this is arrow 4. All right, 4 branches, okay, in a parallel connection. All right, so let's flow. So I need to get the resistance arrow 2, which is X. So how do I do that? I need to get the voltage across arrow 2. Remember, the voltage across these resistors are the same. You know that already. So which simply means that if I can use Ohm's law to get the voltage across arrow 1, okay, which of course is I1 R1. And I already know from what I have here, the current across arrow 1 is 5 ampere, and the resistance of arrow 1 is 6 ohms. So that's simply gonna be 5 times 6. 5 times 6, of course, is 30 volts. So the voltage across arrow 1 is 30 volts. And it happens that arrow 1 is in parallel with every other branches, okay? So invariably, I think it's a question here. It's a question here, okay? The question is for me to get the value of X, okay? So I need to get that value of X before I can now apply the uh, current divider, okay? Remember, this current divides among these 4 resistors in ratios. So first of all, I need to get the resistor in the second branch. So the resistor X, which of course I call arrow 2 in my second branch, is going to be equal to the voltage, okay? V2, of course, divided by, okay, okay, I gotten my V2. Okay, yet I don't have the current. Okay. All right, let's flow. Let's flow. So since I've gotten my V2, I'll apply Ohm's law. Remember, according to Ohm's law, the total voltage, okay, is going to be equal to the the total current, which of course is 10 ampere, right, multiplied by the total resistance. That way, I can be able to find the unknown resistance. Okay, the total voltage is still going to be the voltage across the parallel connection is 30 volts. All right, equal to the total current. The current flowing through is 10 ampere. Then multiply by the total resistance. Okay, so the total resistance for the entire parallel connection, let's evaluate that. Don't forget this 1 all over R total. That's equal to 1 all over R1 plus 1 all over R2, which of course is X, plus 1 all over R3 plus 1 all over R4, right? All right, so now that's going to be 1 all over RT. Total is going to be equal to, what is my R1? 6, 30, 50. So I'm going to have 1 all over 6 plus 1 all over X plus 1 all over, what do I, okay, R3 is 30, then plus 1 all over 15. So LCM of all this, 6x 30 15 is going to be 30x. So I put that 30x. Of course, 30x divided by 6, that's going to give me 5x. 5x multiplied by 1, that's 5x. Okay, so of course here, 30x divided by x, that's 30. 30 multiplied by 1, that's going to be 30. Plus 30 divided by 30 is, all right, I'm just have x multiplied by 1 I have, that's x. 30x divided by 15, that's gonna give me 2x. 2x multiplied by 1 is 2x. Okay, so 1 all over ROT. Okay, let me still bring this down. So adding up, I'm gonna have 5x plus x plus 2x. That's 6x. Okay, everything's gonna be 8x, right? 8x. I'm having 8x plus 30 all over 30x. That's 1 all over RT. But remember, what I'm looking for is RT, not 1 all over RT. So invariably now, for me to be able to get RT now, I have to reverse. Okay, so 30x will go come up, then now divided by 8x, then plus 30. Okay, so I've gotten what I'm looking for now. We can now flow with getting my unknown resistor X. Okay, so let's flow with that. Here we go. So this is going to be 10 multiplied by 30x divided by 8x plus 30. Okay, so now I have to rearrange the equation right up. I have to cross multiply. So this of course is going to be 300x. Or to make it easier for me, zeros cancel zeros, both sides, okay? So I can cross multiply. 30 multiplied by 1 will give me 30x. Then 3 multiplied by 8. 3 multiplied by 8, what's that? That should be 24. Okay, yeah, 24. 24x. Then plus 3 multiplied by 30, that's going to be 90. So rearranging the equation, I'm going to have 30x. 24 comes over minus 24x equal to 90. So if I subtract it, that's going to give me 6s, right? Yep, equal to 90. That way, x is going to be equal to 90 all over 6x. 90 all over 6, please pardon me. Okay, so 90 divided by 6, that's 15. So 50 ohm. All right, so I've gotten that. Now the next is for us to get the current across each of these resistors. Says, of course, S is 15. Says 15, 30, okay, 15. So you know very well that, let me divide that. Okay, let's start with the very first one, that is R1, which is 6. Okay, so I'm going to apply current divider. Okay, so that's I1. Okay, already I've gotten the current for I1. The current for I1 is 5 ampere. Let's get the one of I2. The current passing through uh, I2, that is passing through X. Okay, the resistance S is 15 ampere. So I2, the current passing through X is going to be equal to, of course, you know what that's going to be. That's going to be equal to their ratios, okay? That's going to be resistance R2 divided by the total resistance multiplied by the total cycle current. All right, so this is going to be equal to the resistance R2 is the X that we've actually found, which gives us 15. Okay, and our total resistance, what was our total resistance? Okay, let's evaluate our total resistance. Our total resistance. If we should put the value of 15 into this, my total resistance is going to be equal to 30 times 15, right? Divided by 8 times 15 plus 30. So let me just get that at once. All right, so let's do that. 30 times 15. That's giving me 450. Then divided by, okay, bracket open. 8 times 15, then plus 30. Alright, bracket close equal to, that's 3. Okay, so my total resistance is 3. Okay, so I'm gonna have 15 divided by 3, then multiply by the total current, 10. Okay, alright, so okay, let's do that. 15 over 3 is 5, so 5 times 10, so I2 will be 50 ampere. Okay, okay, am I mistaken? Alright, so invariably, so that's how we actually get I3, okay, and of course I4 using the current divider. Okay, so we are going to work on more, but before then, let's look at other law, okay, of direct current. Now, see you in the next video. Thank you very much.